Hey, this is Mr. Evans. I'm going to do a video here showing you how to accomplish this week's exercise. This exercise will be due next Wednesday. I've made Wednesday the due dates instead of Fridays because that gives me time to get everything ready for you guys. So you will actually have a little bit more than a week to get this one done. But so what I'm going to do now is I'm going to access the exercise. And in case you've forgotten how to do that, that's the reason I wanted to show you. So I'm going to click on the Learning Center. And here it comes. I'll scroll down a little bit, click on Self-Paced Courses. I want to go to my Learning Pathways. I want to choose CAD Basics. And then there's only one pathway here. I'll click on that. And you will see, those of you who have done your exercises already will see this. Obviously, this one I did not require you to do it all, but this one right here should show as completed for you guys because you should have done all this. And so the next thing we're going to do is Introduction to Assembly Design, which is basically, you can see here, we're going to take various parts and put them together into an assembly. This is something that you guys had not even learned how to do yet in SOLIDWORKS, so this will be good stuff for you. So we're going to go to Continue. And of course in mine, you can see that I have all the checks because I've done all this already. And so you will watch the videos that will show you everything that we're going to be doing. And so if you'll watch this, this will give you some preparation. There's some self-checks that are pretty easy, but give you instant feedback as to whether or not you understand everything. And then how to insert parts and how to reposition parts. And so we're going to go to this exercise now where we are going to actually insert and reposition a part. So I'll click on the exercise. And here we are on the first page, and Insert and Rotate Instant Exercise. We're going to insert a part into an assembly, and then we're going to reorient and reposition the part with the triad manipulator, and then we're going to fix a part. Fix means you have to put it in a certain place where it can't move. And when you're doing an assembly that needs to move, you have to have at least one fixed part. Otherwise, the entire assembly moves instead of just the stuff you want to move. So I will go to the next page. And so what we have to do is we have to access the exercise. They're going to give us some pre-drawn parts for this because we're just learning how to put parts into an assembly and how to make the assembly. So we're going to follow this. Open the public document exercise : universal joint. And it actually has a link to that. I'm not going to use that though. I'm going to show you how to do the search. So I'm going to go back here where you guys will have, you'll be logged on to Onshape just like I am. We're going to type in, first off, we want to look in public. So there it is. We'll type in EXERCISE : UNIVERSAL JOINT. And then we'll just do a search on that. And so you can see that you have a lot of them that say copy. These are ones that other people have downloaded and copied. So you don't want to use these. They've just made these publics. These belong to other people. You can see that they're different names. This is the one you want, the one that says Exercise Universal Joint Exercise. So you'll click on that, and that will open up into your Onshape. And you can see this is a normal part, all the extrudes and everything, but we are supposed to make an assembly. So the next step says, after we have loaded it, it says select the plus sign in the bottom left and choose Create Assembly. So as I said, this right now is just a part. So we're going to make a copy of it first. I think we must have skipped that. We want to make a copy. It will not let us change this. So we have to make a copy. And we can just make it the same name, copy. So we'll click OK. And after we have made a copy of it, let me go back to here. I must have skipped that because select make a copy. So you can see that I actually skipped that. So our next slide now is to select the plus sign. My big clue was that there was no plus sign. Now there is. Now that we've made a copy, we have a plus sign. I'll click on the plus sign and Create Assembly. You can see that now the design tree changes. It just shows really nothing right now. There's nothing in here. And so we'll go to the next step. The next step is to click on the insert, click on universal joint, and then click on the check. And that's what, if you read that, that's what it says. We're going to click on insert, click on universal joint flange, and then click on the check. So that's what we're going to do. We're going to click on insert. We're going to click on universal joint flange, and then we're going to click the check. So now we have inserted this part into our drawing, our assembly rather. So now that we've got that done, let's go to the next. Okay, so it says select the part to display the triad manipulator, then drag and drop the triad from the center circle to the point mate connector point that is centered. Well, so let's do that. Right now you can see this is fit in the wrong place. So if I actually click on the part, it selects it. I apologize for looking down here. That's just for mates. We haven't done any mates yet. I click on the part, and you can see I get this triad. And so if you watch the videos, you see if you click on the little round thing here with the lines, I can just click on that and drag, and I can rotate that to where it looks like kind of like what it does in the exercise. And then it says click on this in the center and drag it down to it's in the center. You can see it changes. So that's exactly what we do. So we've got that in the middle. So we have drug it right there like we're supposed to. The mate connector automatically pointed and did what it's supposed to do. So now we'll go to the next slide. So now what we're supposed to do is move to the center, right click on the center circle and choose move to origin. So we're going to right click on the center and click move to origin. Now this is important. This is the origin in an on-shape drawing, and if you don't have your part connected to the origin at the right spot, all of your center of mass calculations will be incorrect, and we're going to have situations where we have to look for a center of mass. I mean, if you want to get the right answer, and this is the same whether you're in SolidWorks or Onshape, you always have to have your origin in the right spot. And so what it's saying is to right click on this circle and click move to origin. And you can see that now that is actually moved. It is coincident with my origin, which is what we're supposed to do. So let's go to the next step. Now it says to orient the part so it's facing upwards, right click on the arrow of the triad manipulator that is normal to the selected face and choose align with Z. Okay, so here's our face that we want to be normal to. This right here is the arrow that is normal to, because it's the one that goes right dead into that face. That one doesn't, that one doesn't. So I'm going to right click on this one and click on align with Z. And you can see that it's now not upside down the way it was when we brought it in. It's now aligned perfectly with our Z axis. And we have our X and Y axis as well, now perfectly aligned. So this is exactly what we wanted to do. We are now oriented properly. So the part should be facing right side up, opposite to how it was modeled in the Part Studio, and that is correct, it is. All right, to fix the part in space, right click anywhere on the part and select fix. So I'm going to right click anywhere on the part and I'm going to select fix. And you'll notice that when I selected fix, I get this little symbol that says it's fixed, and then I can no longer, that little symbol to rotate things doesn't even come up anymore. It is fixed in space exactly where it's supposed to be. It cannot be moved. So we've got that done. Now it says select the instance of the list and then the mass properties. And so we're going to do that. And notice that they've got the mass properties kind of blocked out here where you can't see them. But we're going to click on this. That selects the whole thing. When we do that, we get our little scale here for our mass properties. So I'll click on that, and our mass properties are now displayed. And obviously they're going to ask us for a center of mass. So we're going to look at our center of mass. X is 0.004, Y is 4.242, and Z is a negative 0.331. So let's take a look at that. We will go to, we're on slide 8 of 8, so now we have to go up here to the next page. And it says, check to see if your assembly is correct. Begin self-check. So we'll click on that. And so what we want to do is we want to find which one of these match our mass properties. Well, I can tell you, remember that we had 4.242 and 0.004, and that right there, that negative 0.331 is the only one that's negative. And so there's only one negative 0.331. Oh, actually there's two. So we better check here. But that, see, that one there has a negative 4.24 as well. So that is not right. So this has to be the correct answer, I'm thinking. So I'm going to click here, see results, crunching numbers. That's correct. So that's how you'll know when you're correct. And then, so when you're correct, this is all you have to do now is do a screenshot of this. And your screenshot is what you're going to turn into Google Classroom, and that will give you credit for this week's assignment. Good luck. If you guys have any problems, you can email me. I also will remind you that on Fridays, I have a Google Meet session where you can actually join in and talk to me face to face. And I can actually demonstrate my screen and show you guys exactly how I did things if you're having problems. So I'll send you guys out an email later on this week, so you'll have the link. All you have to do is click on the link and then click join. That will be at 10 o'clock a.m. on Friday. So you guys take care. Have a good one.